Morning, class. How you all doing? Well, yesterday I illustrated how to graph the parent slash basic graph of y equals sine of x. And hopefully you went home and you practiced it. And today you came back and you are experts. Anyone have any questions? Cool. So today we're going to take that parent graph and we're going to move it left and right and up and down. And we're going to vertically shift it and vertically stretch it and vertically shrink it. And we're going to do all these transformations on it. And the general form to graph any sine curve is right here. And today, right now, I am going to show you how to graph that particular one. And I will show you how to graph it. And then either later today or tomorrow, we will do X number of these together. And then I will send you home to do Y number of these on your own. And then you'll come back tomorrow and I'll take concerns. And after I take concerns and I make sure you're all with me, then you'll all be experts. Now, the beauty of this is that once you become a graphing sine expert, in essence, you become a graphing cosine expert because they're done exactly the same way. The only difference is the acronym, which is just the shape of the graph. Moreover, an additional beauty of all this is once you become an expert in graphing sine and cosine, you in essence become an expert in graphing cosecant and secant because you do everything the same way. There's just an additional 1/2 steps. And we'll do the same thing. I'll illustrate, we'll practice some of them together in class, then you go home and then you practice on your own, and then I'll take questions, and voila, we're all experts. Sound like fun? Let's do it. So the first thing you do is you list these 5 things in this exact order. The acronym, the amplitude, the period, horizontal shift, and the vertical shift in that exact order. And then when we get to the graphing part, we're going to actually apply these in the exact reverse order. Okay, so the acronym for sine happens to be E-MIM-ME. Created by me and illustrated by me yesterday with the parent graph. Now the amplitude is the absolute value of A, and the absolute value of 2 is 2. Now the period is found by taking 2 pi, which is a fundamental period of the basic sine curve, the parent graph, and dividing it by the absolute value of B. And 2 pi divided by 1/3 is 6 pi. If anyone needs me to show you how I got that, I will do that off to the side. Now, the horizontal shift is denoted by C, and I think it's obvious that C would be 2 pi over 5. Because it's positive, the shift is to the right. Likewise, the vertical shift, which is denoted by D, I think that's also obvious. That would be 5, and because it's positive, then that would be 5 up. And there we go. Those are the 5 things that we need to list. Now, to graph this, we're going to graph this in the exact reverse order. Now, firstly, I will draw my axes. And don't forget to label your axes. And don't forget to put arrows on the axes because axes are lines. So now we're going to apply these 5 things in the exact reverse order. So now we're going to do the vertical shift. So we're going to go 5 up, 1, 2, 3, 4, 5, and try to make those as equally spaced as possible. And in essence, what we just did is we took the x-axis, the midline, the middle of the frame, which I will speak to soon, and we moved it 5 up. And we're going to put a broken line there to distinguish it from the x-axis. And then we'll come over here and we'll put a little check mark because that is now done. So now we're going to apply the horizontal shift, which is 2 pi over 5 to the right. Now 2 pi over 5 isn't much, so just go a little bit, put a mark, and write 2 pi over 5. What we just did there was we took the left part of the frame and moved it 2 pi over 5 to the right. We took the origin of the parent graph and moved it 2 pi over 5 to the right. And we'll come over here and we'll put a check mark because we just did that. All right, now the period 6 pi. Now the period is the length of the frame. It's how much arc length you need to create one period / cycle of the graph. So you're going to start at 2 pi over 5 and you're going to move 6 pi to the right. So we'll just go an arbitrary amount and we'll just put a little mark right here, which will be the end of the frame. Now, students typically want to write 6 pi there. Now that would be 6 pi if you had started at 0. And then if you move to the right 6 pi, you'd end at 6 pi. However, in this case, we're not starting at 0, we're starting at 2 pi over 5, and we're moving 6 pi to the right. So what we need to do is we need to add 6 pi to 2 pi over 5. Now you cannot add a fraction to a whole number unless you have a common denominator. So we'll change 6 pi to 30 pi over 5. Some would not know how I got that. I'll do it off to the side. And 2 plus 30 is 32. So I will write 32 pi over 5 right there. And that's the end of the frame. Over here, put a check mark and say done. Now what we need to do is we need to create the other 3 key points. So altogether we have 5 key points because we use the 5 key points to actually sketch the curve. So what you need to do, you need to split the middle. I'm going to just do my best to go right in the middle, put a mark. Now to find the middle between 2 pi over 5 and 32 pi over 5 is the average. So you have to add up the 2 pi over 5 and the 32 pi over 5 and divide by 2. And 2 plus 32 is 34 pi over 5, and half of 34 pi over 5 is 17 pi over 5. We good? All right. Now we have to split the middle here and split the middle here, and now we create the 5 key points. So we're going to do the same thing again. Now 2 plus 17 is 19 pi over 5. But 19 is an odd number. So you can't just, so to take 1/2 of 19 pi over 5, that would be 19 pi over 10. So in essence, you multiply the denominator by 2. So we get 19 pi over 10. And we're going to do the same thing to get this key point right there. So 17 plus 32 is 49. And 1/2 of 49 pi over 5 would be 49 pi over 10. And there are your 5 key points. And we'll come back to them, and we'll use them to create the actual shape of the graph. So now we need to apply the amplitude, which is 2, which means from 5, the amplitude is how much up and down you go from the middle of the frame, the midline, to get to the top of the bottom, the max and the min. So we're going to go 2 up, put a 7, and go 2 down, and put a 3. And there we go. We come over here, we put a check mark, and we go, done. And now we're ready to create the frame. Now, Z number of years ago, someone showed me this framing concept, and I love it. I've been using it ever since, and my students typically love it. And now I'm going to show you how we apply it. So I'm going to make the frame. The left part of the frame will be 2 pi over 5, and the top will be 7, the bottom will be 3. And then I'm going to go all the way over here and stop at 32 pi over 5, and that would be the end of the frame. And if you do this fairly accurately, the broken line, the midline, the middle of the frame would be right smack in the middle. Beautiful. Okay. So now we're ready to use the acronym to actually create the shape of the curve. So at the first key point at 2 pi over 5, you have an I, an intercept. Now that's not an intercept of the graph per se, but it's an intercept of the parent graph. It's an intercept of y equals sine of x, because we took that intercept and we moved it to the right and we moved it up. So the first point, even though I call it an intercept right there, it's really an intercept that was transformed, but we still call it an intercept. Okay, now the second key point is at 19 pi over 10, and there we have a uppercase M, which stands for the max, which in this case would be the top of the frame. So we're going to go to the top of the frame and put a nice big distinguishable point. Yay. And then the next letter in the acronym is little I. It's another intercept, transform intercept. And then we got lowercase m, which stands for the minimum, which is the bottom of the frame. So there I'm going to go to the bottom of the frame with the 4th key point. And lastly, we have another transform intercept. And now you're going to use these 5 points to smoothly and symmetrically graph this sine curve. Gorgeous. 20 points for me.